Hi there, my name is Georgia Collins. I'm a junior from Archbishop Carroll High School in Dayton, Ohio, and I study the effect of neural oscillation frequency on episodic memory. Now, a neural oscillation is just another name for a brainwave, and brainwaves are made up of bioelectricity that surges between two neurons across the brain at all times to communicate a message or an idea, and the rate at which these brainwaves fire determines what kind of brainwave it is, what category it is. There's 5 different categories of brainwaves, being delta, theta, alpha, beta, and gamma waves, and each of the 5 waves has a huge effect on a person's how they process information and how they think, how they talk to themselves, and what they do, because it has a huge effect on the limbic system. It changes how the limbic system works and functions. The limbic system is a system within the brain that has to do with processing information, responding to events, motivation, emotion, and memory. How it works is as we go through an event, as we process information due to sensory around us, it goes through the cingulate gyrus and the thalamus and amygdala, which help to process what's going on, respond to an event, and also the emotional response to an event. And then once it goes through those 3 parts of the brain, it ends up in the hippocampus, which the hippocampus has everything to do with memory. So as we go through an event, as it's happening, the hippocampus is processing it and encoding it into the brain, which is the first step of memory. Then it stores it, and then depending on what we need of that event, it recalls it when it's necessary. And the hippocampus has a really big effect on a person's mental and physical well-being, especially later in life, because either due to predetermined genetics or bad diet or just old age, the hippocampus starts to shrink. It loses mass and volume in the brain, which 10 times out of 10 causes a person to develop Alzheimer's disease. Now, once Alzheimer's disease develops, there's really no going back. There's no fixing the hippocampus, even though there are treatments that exist to make a person more comfortable once they've developed this disease. But really, there's no way to gain that size, that volume in the brain back. But research has been done to show that when a person is younger, from in their teens or their 20s or even into their early 30s, that the hippocampus can actually grow. MRIs have been done to show a comparison of a person's brain between 2 months, and that the hippocampus can grow instead of shrink, which we don't really know why it happens. We just know that it does happen and that it can be done. I personally believe that if the hippocampus is able to grow a lot when a person is in their younger years, that this can kind of be used as a defense against it shrinking to a very small size when they're older, which in turn will help prevent them from developing Alzheimer's disease. But really no studies have been done to show if or what it is that makes the hippocampus grow, what's good for it, aside from a good diet with leafy greens. So I wanted to find what it is if the rate at which a person's brainwaves fire has an effect on a person's memory, in turn to discover if there is 1 or 2 different brainwaves out of the 5 that can help grow the hippocampus. How I did this was I tested 25 people between 13 and 25 years old, so on the younger side of the target age for growing the hippocampus. I had them tested one at a time, where I had them put in headphones and listen to a sound for 90 seconds. Now, that sound was a frequency produced by an app on my phone. This is because of a neurocognitive process called neurofeedback. Neurofeedback is kind of a phenomenon that happens in the brain. We don't really know why it happens, we just know that it does happen when a person experiences either a visual, auditory, or physical stimulation of a frequency, that the brainwaves will interpret that frequency that it is observing and fire the brainwaves to that frequency, the biological equivalent to the frequency that's being observed. So an example of this was I had my participants, each of them listen to 40 hertz for 90 seconds, which their brainwaves saw. They interpreted those 40 hertz sounds and produced the delta waves, which I think is really cool that a person can see or hear or feel a frequency and produce brainwaves to the equivalent of that frequency. So I had them listen to 40 hertz for delta waves, 70 hertz for theta waves, 100 hertz for alpha waves, 180 hertz for beta waves, and then 220 hertz for gamma waves. I tested in different orders, so I didn't go in that order every time. But they listened to 40 hertz for 90 seconds, and then they continued to listen to that sound while I held up 12 cards out of a deck at random, and I asked them to just remember as much as they can about those cards while they listen to the sound. So I held up those 12 cards, I put them down, and then I splayed them out for only myself to see, and then I asked the participant, I turned the sound off, and I asked them to tell me exactly what they remember about those cards to the extent that they remember it. So I was looking at the cards and keeping track of what they got right and what they got wrong, and then I interpreted that, what they got right and what they got wrong, into a point system. The point system was something that I created. They received 1 point for getting the number of the card right. They got 1 point for getting the suit right. And so each card had a possibility of getting 2 points. So if that number or that card, if the number and the suit were in the deck at all, they got 2 points. If the number was in the deck, they got 1 point. So that makes 24 points for the 12 cards, and then I added 2 more points, or a possibility of getting 2 more extra points if all the cards were said perfectly in order. They're in the order that they saw them. And then after they told me what they remember, we did it over again 4 more times, with each of the 4 remaining frequencies. So tested in a different order every time, but used a different 12 cards every time as well. And then, after I tested each person, I did it again. And so that made up 25 people, and that kind of brings me to my results. What I found from the points that were awarded, depending on what they got right and what they got wrong, I expected to see that between alpha waves and beta waves, that these 2 waves would produce the best memory. I thought that this would happen because of the different characteristics, the different effects that these two waves have on how a person thinks. Alpha and beta waves typically are seen when a person is highly cognitive and thinking heavily, which I associated with remembering a lot. So I was thinking that if a person is highly cognitive, then they'll remember a lot from being highly cognitive. But this wasn't exactly what I saw in my data. My data suggested that on average, theta waves, which was when they were listening to 70 hertz, produced the best episodic memory. They remembered the most when they were producing theta waves. Now, I didn't really know why this happened. Like I said, not a lot of research has been done before to see if a certain brainwave has an effect on memory. So I went back and I did a lot of research as to what theta waves really are, and I found a study done by the University of Pennsylvania a couple years ago, and UPenn found that theta waves actually are seen, they cause a really good association between cognitive and emotional responses to an event. So as we process information, it causes the emotional side of things to link up heavily to what we actually experience, which in turn causes the best memory. Now, theta waves did do the best, but next to that, alpha and beta waves tied for second place, so I was right that they would make a person highly cognitive and then remember stuff, and then after alpha and beta waves, gamma waves was second to last, and then delta waves were just not good. Specifically, theta waves on average earned 15 points out of the 26 available, and delta waves produced 10 to 11 on average. So there is a big difference between what the memories that theta waves produce and the memories between that delta waves produce, and in between. What this suggests in conclusion is that theta waves might be the best waves for producing memories, and the best waves for the hippocampus to function, which hopefully, with further research, can be used to find whether or not theta waves, when a person is producing theta waves due to neurofeedback when they either listen to or see a visual stimulation, would be the best for growing the hippocampus and preventing a person from developing Alzheimer's in the future, which I believe can be tremendous in the medical field when it comes to getting a person their right to their memories back. In conclusion, if I were to do this all over again, I would want to change up something, a small part of my procedure. Instead of testing one person 5 times for 5 different brainwaves, having them change their brainwaves every couple minutes to test them, I would rather test one person 5 times for one specific brainwave, which I think would have a more concrete representation of each brainwave instead of comparing that person 5 different times for that one brainwave. It would kind of make each brainwave's data a little bit more solid. Not to say that my data is not solid, but I think that instead of having them switch their brainwaves 5 different times, to just get them producing one frequency of brainwave and then test that 5 different times. And that was my research. Thank you so much for your time.